So what? You are recording, okay? So let's be more official. Artem is an associate professor in Ukrainian. Artem, help me with the name of your faculty and university, please.
You can read
It's
it from the
in
slides.
Kyiv.
It's
Yeah, it's in
National
Kyiv. National. Yeah, I can see it on the slide. Sorry, National Technical University of Ukraine, and we know each other from some cooperations with or over European projects. I know Artem that they are focused, and his research group is focused on artificial intelligence and image processing, and they are also doing some robotics. So I will give him the word to present himself and his research group.
Thank you very much. First of all, let me introduce a bit our university and our department. Our department is Automation Hardware and Software. We are developing some hardware for metallurgy for different areas of industry, also for healthcare. We are also developing some software products for healthcare based on artificial intelligence, computer vision techniques. We are also developing some robotic solutions for them. And that's why the topic of today's seminar is artificial intelligence and robotics as the means to overcome arising global challenges and everyday issues. Automation, our department belongs to National Technical University of Ukraine, Igor Sikorsky Kyiv Polytechnic Institute, which is located in Kyiv, the capital of Ukraine, and was founded in 1898. Trains more than 20,000 students per year, and our university is top rank university and the largest technical university in Ukraine. We have more than 16 faculties, 11 educational and scientific institutes. Also, we have research institutes, educational centers, so on and so forth. Our main building shown on these photos, and also our department is located one of the 25 buildings for our campus. It's building number 19th. The most famous graduates of our universities are Igor Sikorsky. Probably you know who is he, and he studied 97 and 1911 at our university. He is founder of Sikorsky Aircraft Corporation, and he's the person who built his first helicopter at our university. Also, Eugene Paton in English, the inventor of electrical welding, and Sergei Korolev, Soviet rocket engineer who played central role in space race, and he launched the first people Yuri Gagarin to the space. United Nations in 2015 set out a new agenda for 17 sustainable development goals, which guide us into the better future. That's why these goals also presented on these slides, and I would like to say that humanity facing many global changes that manifest themselves so strongly and so dramatically. Some of them is healthcare. The main problem of last decades is COVID-19 and pandemic. Peace and justice, war in Ukraine, and industrial innovations. Let me describe some of our ideas and some of our research we have done. And the first of one is focused on the healthcare. It's a co-security system which we developed for one of our state institution, which works following two different scenarios. The first one is when the person with digital key come to the checkpoint, he has to get permit to go into the institution. Therefore, we should to check if the person wear his mask correctly. This is the first stage. If the person wear his mask correctly, that's okay. The person is allowed to go to the industrial environment. Another way, another scenario, when the person don't wear his mask properly, or don't have the mask at least, we should lock the door and don't give a permit to go into. That's why we also should inform this person that he or she need to wear the mask. Otherwise, he will be he he will not give the permit. Another scenario, it's focused for multiple person recognizing. We recognize the mask, and if the person don't wear his mask correctly somewhere in a corridor, even he is already on the working environment, the security camera watching on these persons, and if some of them don't want to wear the mask, or all of us, we are persons, we are humans, and can relax somewhere, and if we are out of which we can relax and do not wear the mask. That's why we should inform a pop-up message on the Telegram as soon as the person do not have the mask on his face. Also, we should recognize this person by the multiple cameras and follow them from one environment to another. We used quite simple approach, three-layer convolution network, and our database consists of about 10,000 samples for training, for all amount of staff employed at this institution. We test different types of networks and find out that the most efficient, the most accurate was three-layer convolution network. Let me show you how it works in real life. And the person have his pandemic bot on the Telegram. We recognize him, and even he has his mask on the face, but don't wear it properly. We also inform this person that it's not allowed him to wear the mask in a such way, and he should put the mask to hide his nose and mouth. It's also possible to detect different persons and recognize their personality. Here's one of our developer, Kirill Haiduk. Another research we have done also focused on this pandemic problems, but here we solve the problem with sound detection and domestic action recognition based on this sound recognizer. We tried to improve the accuracy of the existing approach. Therefore, we based our ideas on some studies which is presented in the famous journals. We used the similar approach, but to increase the accuracy, we use the difference in the networks and our idea approach. First of all, we have a set of microphones mounted in the living environment and different rooms somewhere at home. The purpose is to detect domestic actions. If person cough or if person fall down somewhere, we should detect these sounds and inform the ambulance, call for ambulance before the accident happens. It's the goal is to predict the hazard development and to prevent healthcare system overloading. Our idea is the further. First of all, we collecting waveform from the sound. Then we convert our raw signal to the null spectrograms using Librosa library. From the null spectrogram, we convert these spectrogram into the PNG feature map and send this image also to the 3-layer solution network, which is architecture is present on this slide. For each spectrogram, we compute natural logarithm of mLs element-wise, scale up to fit inside 8-bit range, put low frequency at the bottom in the image, invert image, and save in PNG. Then our artificial network, neural network, is able to recognize the sound, to classify them, and our approach allows us to decrease the accuracy up to 92%. The previous study gave the accuracy about 80%. Also, the biggest challenge of this research was to detect the silence and some actions which is very short in time. For example, the most difficult was to detect the slam sound, and also it depends on the room. Therefore, it's open for our research is open for further development and improvement, and we are working on this.
Excuse me, how many speakers you concerned?
It's for particularly we use this system for a single living person. It's for elderlies who has not the person to observe them, and we use this system for single living person. Sorry, may I go further, or do you have any additional questions?
Thank you. That's clear. Thank you.
Our another project we started this development right before the war, and it's REP, our walking rescue robot. It's an ongoing project. We are developing these on the very first stage, but for today we develop just mechanical design. The idea is to develop working robots, which is able to move in the complex environment, complex terrain, and to move the person on top, some wounded person, and this robot should assist rescue teams somewhere in mountains. But after the war starts, we suggested to use our research and our robot also for rescue teams who works somewhere in Ukraine. And these pictures we see how our buildings are destroyed. Therefore, our robots and our ideas very important for Ukrainian nowadays. The idea is quite interesting. The first, we should keep our top platform stable and robust for different environment, for different terrains, because we have no roads, we have no lines to detect if we need somewhere to move, and therefore we should detect the obstacles considering complex and rocky terrain. And also the open issue is path planning and correction. Unfortunately, we are on the first stage, and as I said before, so we are dealing with platform stability. Our robot is about half a meter in height, and its payload is about 150 kilograms. We modeling our static and in some experiments we put the load on the different part of our robot and shows you how the differs the displacements are depending on the loads on this and on the area we put our load. Therefore, the maximum is for fourth and fifth experiment. It's the trials we put our load on the top and on the backside. Also, the maximal stress depends on the load, and these graphs shows us these dependencies. This research is ongoing, and it would be great if someone would suggest us to give us suggestions, or also join our our group to develop such a robot for everyone, for European countries and for Ukraine as well. Another application, it's not about the global challenges, but it's about AI for definition of chemical composition of metal-containing substances. This idea was to improve state-of-the-art methods because to define chemical composition in metals. Because Ukraine, as you know, it's one of the biggest exporter of metal in worldwide and Europe. In 2020, Ukraine exported 136 million tons of steel products to European countries and took his fifth place. Chemical composition of metal-containing substances is extremely important and specific task for metallurgy. We should detect these composition and includes and should do these as fast as possible. and as well as accurate as possible. That's why we develop our system, because the existing methods has the accuracy about 40%. They're based on different type of spectrometers. It's thermal optical spectrometers, spectrophotometers, and so on and so forth. The most famous companies is Thermo Scientific, located in United States, ULab in China, and Iskron in Russia. The cons of all of them is, first of all, the duration of definition. It takes up to 1 minute and quite poor accuracy. For example, for Iskron, the accuracy varies from 0.5% to 40%, depends on the materials and depends on the metals. We are using for our ideas intelligent, precise kinematic system, which measure the angles of the laser array rise. Our system consists of driver, table, rotating device, ring laser, autocollimator, laser emitter, and photo sensor, which is allow us to detect and to collect the spectrogram of the material. Then our spectrogram, it is well known that depends on the substances and chemical composition, the spectrogram will rise. That's why we are analyzing the spectrograms for the known chemical parts, chemical materials such as mangan, cuprum, ferrum, and so on and so forth, and send our spectrograms to the neural network, which in further recognize the metal in a half of up to 2 seconds. We tried this system to detect aluminum, calcium, bromine, and barium as the most frequently used in metals. The accuracy of our system gives us about 90%, and it's quite fast because we could recognize the chemical composition in from 2 to 3 seconds, comparing to the state-of-the-art methods, which are about 1 minute, and some of them even 2 minutes did the same. And in addition, we also have fully automated system, because the state-of-the-art methods are not automated, and they allow us to just to obtain the spectrograms and then the person should deal with these spectrograms and to compare with different type of metals and substance chemical composition. Thank you very much for your attention. That's not all of our research. We also do some research for mobile robotics. But in general, if you have any questions, I'd like to answer.
Sure, we will have. I have a lot of, but first let other people ask if they have a question. Andrei, you have a question or no? Okay, so I will start with according to your slide. The first question is about the mask recognition software, the
Yes,
face.
that's me.
Did you find some problems when people wear different colors of mask? Because very soon people start to wear different colors, not only white or blue, but also black, red, and different colors. And sometimes it really fools the software.
We had some problems, but due to the restrictions of having different type of masks, it's not allowed for that institution. So
Okay.
it was quite simple. But
Yeah,
sure,
okay.
we had
The problem was solved in the opposite way. Okay.
yeah, yeah.
The
And we
next.
also we tried to, sorry for disrupt. We also tried to recognize the mask even it's face painted, because you know some of
Yes, this is also
guys
really
used
challenging. Yes.
yeah.
Okay, the next question is about the sound recognition. Do you have a recommendation where microphones should be located? Is it on the ceiling, in the corners, or how should they be located in the flat?
It's first of all, this should be, it's one part which consists of 4 microphones, which is mounted in each corner. So this should be mounted in each corner, but on the top by the ceilings.
So for single room, you need 16 microphones?
Yep. But they are not very very sensitive, because they are put in the different directions. We should cover all room. That's why we
Yes, I understand. Okay, so you have pretty big amount of data for that.
yeah.
Okay. So thank you. My third question is that I really like your robot, and I'm surprised with the payload that it can move 150 kilo, if I remember it correctly, in relatively small body. And
Yep.
my question is whether you have a prototype or is it just in the design phase?
Unfortunately, it's just design. We had this and started this model in SolidWorks, but we are going to print its body, but we need time at first,
Yes,
and we
for sure.
need
Which kind
resources.
and which kind of batteries you assume to use?
Lithium batteries, I guess.
Okay.
It might be. It should be about voltage about 12 volts, and current, I guess this might be. Let's study more precisely this way, because I'd like to calculate everything.
That's not a problem. Okay, and will you consider also to search for persons or just transport them? Because you have 2 slides. One in the nature, it's clear that there is the most important thing to transfer the person. But on the second image, I think it's very important also to be able to localize the person. So there are some approaches using thermal cameras, CO2 sensors, and so on. So if you are assuming or thinking about it or not.
Exactly. We are thinking about searching the person, but first of all, we would like to transport the person if it is already founded, and because we cannot use this robot as a full automated autonomous system, because first of all we should to put the person correctly on top of this robot, because it's a founded person. And the most challenging is to find the way to go back to the station or to transport this person to the rescue team camp or to the helicopter somewhere.
Yes, and how it should be controlled by the single operator who will, for example, use a joystick or something like this, or maybe in a semi-autonomous mode when you just tell the robot some points and between the points it will move autonomously, or how it's planned.
For today we are thinking about semi-autonomous, but it depends on the real starting and trials.
Yes, of course.
Because it's very challenging to find the path in such terrain, and even to correct the path.
Yes, maybe
that's why it cannot be autonomous, fully autonomous. It must be semi-autonomous.
Maybe something like person following. There will be a leader, and the robot will follow that person. Okay. And the last question is about the chemical composition. Maybe I didn't understand correctly for first question, why you need so fast detection under 1 minute, and where the samples came from. It's from the metallurgical company, or is from the mining company, or should it locate the samples in the terrain, or where are the samples come? What's the purpose of the detection?
The purpose for both. It's a metallurgical companies on the east of which was on the east of Ukraine before the war, and even for our research institute belongs to National Academy of Science. It's a metal physics institute. They need such fast detection. They didn't tell us why they need this speed, but they need it as fast as possible.
Okay,
that's
because
why.
Because what I know till now about this chemical detection and analysis, 1 minute is great number. It's quite fast, because sometimes chemical analysis may take days. Not minute, days. So it's quite fast, and I'm surprised that you need much faster.
They, I guess, they have a lot of different type of metals and make a lot of trials. That's why they try to do this as fast as possible.
Okay, and
because more time, more power, and also it's not financial efficient for them.
And did you heard about, or did you consider also analyzing the samples coming from the ocean floor? Because all over the world there are special metal concretes, I don't know, stones or something lying on the ocean floor, and many countries are trying to pick up those samples and get a metal from it. So maybe it will be useful also for analysis of these samples from the ocean floor.
It's a great idea. I hope we could also work in such way, but we didn't consider these during that study.
I know about the one recent research, because even Slovakia, which has no ocean around the border, has a special area somewhere in the Northern Sea when we can collect those metal samples, and we were trying to use it somehow. So it may be useful also for this research. Okay, thank you very much for your answers. Anybody else has any questions? Don't hesitate, ask. Or if you are not able to ask on microphone, you can also write your question in the chat.
I would have one. Can you go back to the voice commands recognition?
Yes, sure. Which one?
Yeah, and this network looks like a RESTnet network.
Yep.
And my question is whether there are no these residual connections, or just they are not depicted in the picture.
If I understand you correctly, we used quite similar the architecture to REST network, just with 3 layers, and we put first of all we tried our network on the existing data set from Kaggle. It's open for has open access. Everyone could download this data set, and we played with number of layers. We played with the size of layers, with different types of layers. We played with composing max pool and leaky relu with different type of activation layer, and this architecture was the best and gave us the most accurate results in sound recognition.
Okay, Andrei, is it okay? Ferois wants to ask something or add something.
Yeah, so hi again, Artem. I probably know best you, but I have also several questions. How big is your research group, and how many PhD students you have in your research group?
We have 5 PhD students, and our research group consists of 10 persons. It's 3 Doctor of Science, and the rest of our team is PhD associate professors, and our PhD students, they're working with our research group, but sometimes they do some different problems for in our groups. That's why they are not absolutely a part of our team. We are involving them for the projects, but it depends on the task.
Okay, and I would like to ask more about the mobile robotics. What is the focus of your research in mobile robotics? Is it more the construction of the robots or the control of the robots, or both of them?
No, it's more we are focusing on the control of robots, not on the construction.
Okay,
because
so
it depends on our Ukrainian reality. Sometimes it's quite difficult to have to buy some materials, some equipments, tools. So we are dealing with robots control.
Okay.
Mostly with programming and some methods development.
Perfect. Thank you. And the last comment only. We are also doing very similar chemical decomposition, but we are trying to use hyperspectral camera in one project, and we are using it for welding quality analysis. So, but in the future, we will of course need some ground truth measurements. So I will write you, okay, in the future.
Great. Thank you.
Thank you too.
Okay, so at this moment I would start the recording, and that doesn't mean